we have a set of data, and the set of data is divided into two different segments. One is called the training data set and another is called the testing data set. By using the training data set, what we do, we try to find out the values for M and C so that we can put it in a equation that leads to the line y equals to mx plus c, and this is the line y is equals to mx plus c. And from the testing data, using the testing data set, what we do, we try to find out the value of y from the equation. That is, we find the value of y, we find the value of y by putting the value of x. What does this mean? We take the value of x3, we take the value of x equals to 3, and we have found out the value of m. M is equals to, let us say m is equals to 1.2 and c is equals to 2. Then we try to find out the value of y equals to 1.2 multiplied by this 3 plus c. It becomes 3.6 plus 2, which is equals to, for example, it is equals to 5.6, and this value is called predicted value, y hat, right? Y hat. So for this testing data set, we have the value of x. We'll put the value of x in the equation. This equation is derived from the training data set. Then whatever the value we found out, that becomes the predicted value, which is given in the data set is called the actual value, right? And then here we can see this is the predicted value y hat. Y hat is equals to 5.1, but the actual value is equals to 5. So there is a difference, there is a difference between the actual value and the predicted value, and this is called the error. This is called error. And our main job or our main objective is to minimize this error. If this is equals to 0, then this is known as the best model that we have derived. But practically it is not possible. It is not possible to have a model or to design a model who gives this error equals to 0. And what we do for every data point in the testing data set, we compute this error like this. And when we sum up all the errors from I equals to 1 to n ei, where I equals to the data points, that is all the data points. I belongs to all the data points in the testing data set. So here in the testing data set we have 1, 2, 3, 4, 5 data points. So in this case it will be the sum of I equals to 1 to 6 e of I. But however, what we do when we compute this error, sometimes it comes in negative also. When it will come in negatives, if I say 5 is the actual value y and y hat is equals to say 4.6, in that case y minus y hat will be equals to minus 0.4. So if I do this type of addition or summation of all the elements, sometimes it may lead to 0, because I can have some minus value, negative value 4 or 5, whatever it is, similarly plus 4, then it becomes 0. But this is not actually that we are looking for e equals to 0. This is because of the signs in front of or sign of the error. That's why normally what we do while we compute this error, we square it. Normally errors are computed using square. So instead of this formula, what we do, we sum up all the errors ei squares. This is called, and I equals to 1 to the maximum number of elements in the data set, and this is called sum of squares. Sum of squares. This cost function enables us to determine the effectiveness of the machine learning model. In case of linear regression, mean square error is one of the method, is one of the approach to calculate the cost of the model, right? Error is equals to y predicted minus y actual, and this is taking from the testing data set. But however, this value may have some negative value and positive values. That is why instead of taking only y hat minus y, what we do, we compute the square of this error as y hat minus y, where y hat is the predicted value and y is the actual value. Then we sum up for all the testing data points I equals to 1 till say m, where m is the number of data points in the testing data set. And we compute the sum of all this error square. Mean square error, in order to calculate the mean square error, what we do, this component we divide it by total number of m. We write MSE, mean square error, by taking the average of 1 by m. Then this is the formula for calculating the mean square error. Apart from mean square error, there is another cost function. Another cost function we have in order to do the same, means find the effectiveness of the model. We have another cost function. This cost function is known as R squared value. R squared. So how to calculate r squared value? What we do, we have the, let us calculate first for the r square value for only one independent feature, where if we have only one independent feature, then the equation will be y equals to mx plus c. Mx plus c. We also have y bar, y bar. What is y bar? Y bar is the average of mean of y actual. Y actual. So now we wanted to calculate the r squared value, r squared value, or r squared score. This is also known as r squared score. And this is calculated as, first of all, we will calculate the sum of all this component. We will put this component here, y equals to y minus y hat whole square. Sum of all values from I equals to 1 to m, where m is the total number of elements in the testing data set. Then after it will be divided by the same I equals to 1 to m y minus y bar. Y bar is mean. If I calculate this and we subtract it from 1, that becomes the r squared value. It is called r squared value. And this part is known as total or sum of residuals. Sum of residual. Residual means error. Both the components, this one and this one, will come from the testing data set. Apart from these two, there is one more equation which is known as adjusted r square. We compute the value as 1 minus r square, then m minus 1 divided by n minus p minus 1. This is the equation for adjusted r square value, adjusted r square score. So here E is the predictors. P is all the predictors, or the number of independent features used in the prediction. Used in the prediction, right? So for example, here if I calculate y, or we calculate the predicted value as a0 plus a1 x1 plus a2 x2. In this case, p is equals to 2. This one and this one, 2, right? And this is not m and m. M is the total data points in testing dataset. Testing dataset. Okay. And r square is computed as the formula that we calculated. R square is calculated this way. And if I have all the components r square, the value of m and value of p, then adjusted, this is the formula for calculating the adjusted r square value.